Here I just give one or two examples of finding the equation for an ellipse. So this ellipse has a center of 1, 0, these two vertices, and this minor axis length. It might be useful to graph this. So our center is at 1, 0, right here. Vertices are at negative 3, 0, and 5, 0. And the minor axis length has to be vertical since this is clearly the major axis. And its length is 2, so that means I go 1 up and 1 down to get my points from my center. So here's the ellipse, something like this. And so the idea is, since my center is at 1, 0, that means that the x part of my equation is going to be x minus 1, because when you plug 1 in for x here, you get 0. Okay? Now you have to figure out what y has to be so that when you plug 0 into it, you get 0. And of course, that would be just simply y. So instead of x, I have to be able to plug 1 in to get 0. So I've got x minus 1, so that when I plug 1 in, I get 0. Okay, or you could think about it as x minus whatever this number is. And you could think about y as being y minus 0. Different way to look at it. So the equation for this ellipse is going to be x minus 1 squared over some number plus y squared over some number equals 1. And so to get the numbers in the denominators, I need to measure the distances in my graph. And so the distance from my center to my vertices is 4. So that means the horizontal distance is 4. In my equation here, I have to square that number, so I'll square that and get 16. And that number is going to go with my horizontal variable, which is x. So I'll put the 16 here. My vertical distance from my center is 1. So I have to square the 1, which gives me 1. And that goes with my vertical variable in my equation. So the equation for this ellipse is given here. Notice I did not have to use my foci whatsoever. Okay, I've got a center of 0, 0, so I know I'm going to have x and y with no shifts on them. I know my foci, and I know my minor axis length. So let's graph the center and the foci first. I've got my center and my foci. My minor axis length is 2 square roots of 3, so from my center I have to go half of that in each direction. So I'll go square root of 3 to the right, and I'll go square root of 3 to the left. And so the total distance here is 2 square roots of 3. Now, my ellipse does not look like this. It does not pass through those 4 points because the 6 and negative 6 are my foci, not my vertices. So I have to determine my vertices. So I know my vertices are further away from my center than my foci. So I know my graph is going to look something like this. I just have to determine exactly the distance from my center to a vertex, and then I can finish this problem. So to begin with, it's going to be x squared over something plus y squared over something equals 1. It's x and y, not shifted x and y, because the center's at the origin. And I know my horizontal distance here is square root of 3, so I have to square that and put it with my horizontal variable, which is x, of course. So that when you square the square root of 3, you just get 3. Now I have to figure out what number goes here, so I have to figure out the distance, the vertical distance here. Well, I have not used my foci yet. Well, I know that this distance is v, my vertex distance, from here, let's label it like this actually, is v. I know that's the bigger distance of the 3 that I see. So, setting up the Pythagorean theorem, v squared is going to be 6 squared plus the square root of 3 squared. So v squared is 36 plus 3. So v squared is 39. Therefore v is the square root of 39. So if this distance is the square root of 39, the square of that goes in the equation. So 39 goes here. So really, I could have stopped right here, because my distances are squared in the equation. And here I found the square of v.